Bikes A and B are traveling on perpendicular roads. So let's envision that. Perpendicular roads. At the time, bike A is leaving the intersection at a rate of 2 feet per second. So let's say A is going this way and A prime is 2 feet per second. And B is leaving the intersection at 3 feet per second. So let's say B is going this way. B prime is 3 feet per second. How fast is the distance in feet per second between them changing after 5 seconds? So we think about if A is here and B is here, the distance between them is going to be, let's call it C. At 5 seconds, A of 5 is going to be 10 feet, and B of 5 is going to be 15 feet. So at 5 seconds, C we can find using the Pythagorean theorem. C will be the square root of 15 squared plus 10 squared, or it will be 5 square root 13 feet. And we're looking for how fast is the distance in feet per second between them changing. So we're looking for C prime. So we already see that A, B, and C are connected by the Pythagorean theorem. We need to differentiate these variables with respect to time. They are all changing as A and B continue to drive or ride their bikes. So we get 2A, A prime, plus 2B, B prime, equals 2C, C prime. And remember, we're trying to solve for C prime. So we'll plug in what we know now. 2 times A, which is 10 feet, and A prime is 2 feet per second, plus 2 times B, which is 15 feet, and B prime is 3 feet per second, is 2 times C. C is 5 square root 13 feet, times C prime, which is what we're solving for. So we have 40 plus 90 equals 10 square root 13 C prime, or 130 is 10 square root 13 C prime. To isolate C prime, we divide both sides by 10 square root 13. And we get C prime is 13 over square root 13. We can rationalize that denominator by multiplying by square root of 13 over 13. So we have 13 square root 13 over 13. The 13's cancel. So C prime is square root of 13 feet per second.